can you identify where the metals can be found in the periodic table?
Group 1 and 2.
Group 1, group 2, group 3, then you have a zigzag line, right? In your periodic table.
Group 3 except for boron.
Then there's something like that, right?
Yeah.
Yeah, so then the non-metal, then the metals. So non-metal, we are more or less done because we have done periodic table, and the emphasis is on halogens most of the time, and then the noble gases, which is nothing much. Then the group 6, you only have your oxygen, sulfur, that is more important. Then you have group 4, which is carbon. So non-metals are more or less kind of done. So metals will be a very, very heavy topic for exam also. So it is also covered in bonding, but because metallic bonding is not exactly in your syllabus, so you probably see it touch and go, like you see it once briefly and then it disappears. So okay, so what you need to know is the same. So the first column is the NA. This is NA science, O-level science, and then this is pure chem. Very close. That you will see for D questions from part D, right? Even though they say it's not in syllabus, but you do see it a lot in questions in like in your papers, in the O-level papers, your NA papers, you see the questions again and again and again. So I will not skip those, but just keep in mind, maybe those are not exactly super important if you don't see it in your school teacher's paper, school notes. So without me telling you what are the physical properties of metals, I believe you can already tell me some of the physical properties, right? So there's this thing, they have high melting and boiling point. We kind of know, right? Because you've done primary school science, you've done lower secondary school science, they have talked about it over and over again that metals have, most of them have high melting and boiling points, right? So then there's a second word down here, malleable. Is that a new word to you? Is that a new word to you? I'll put 2 options for you. You let me know if it's new, okay? Just circle it.
No, I forgot what it means.
Okay. So let's assume now we have to do this. Okay, then they're good conductors of heat and electricity. Familiar with this, right? We have done this in physics, right? Metals are good conductor of electricity, non-metals are poor conductor of electricity and heat, right? So now you see physics and chem overlapping a bit. Okay, then back to this high melting and boiling point. Which metals exhibit a different characteristics? Or which metals do not show high melting and boiling point? We have just done this too. Maybe last week, last week. Which metals do not have high melting boiling point? Need help?
Yeah.
Group 1 metals. Group 1 metals have low melting boiling point. They are kind of different from the general metal properties. Okay. Then those with high melting boiling point are group 2 metals, group 3 metals, and the transition metals. Group 1 metals, they all have low melting boiling point. Please revisit. Okay. So metals most of the time are solid, right? Which metal is okay? Name the only metal that is not a solid at room temperature. Which metal is not a solid at room temperature? There is one metal. One. I mean, there's one that you need to know that it is not a solid at room temperature. If you have seen liquid in glass thermometers, you may have seen this metal.
Mercury.
Correct. Very good. So this is mercury. Mercury is a liquid metal. So that means most of the metals are in solid state at room temperature. So how are the atoms arranged in a solid?
Closely packed in a regular arrangement.
Yes. So you can relate that to now the metals here. The metal atoms are packed, as you say, closely packed in a regular arrangement. Okay. So there is not something new to introduce if I've not talked about it. I think I've talked about it, but I say it's not in syllabus. So atoms in metals are held in layers of something called metallic bonding. So in metallic bonding, there's actually you have the atoms, and then the the valence electrons in the metal, they are free to move around. So then there's an electrostatic attraction between the electrons and the positive ions in the center. But for you, you just need to know it's metallic bonding, and you don't have to go into what is metallic bonding. So when they ask you about metals, right, they are always held in a closely packed arrangement, and then they have a strong metallic bond that keeps them together. Just need to know that. Okay, so that's that. Then you have some physical properties. Okay, so okay, let's see if you are agreeable. Metals have shiny surfaces. Agree? High melting boiling point for most metals except for group 1. Group 1. High density. Do all metals have high density?
No.
No. Which metals do not have high density?
Group 1.
Yes. So okay, are there metals that float on water?
No.
There are. There are, I think, 2 or 3 metals that float on water. So which is your lithium, sodium, potassium float on water. Remember, recall. Okay. So you can go back to periodic table, the section on group 1 metals. They will tell you that certain metals in group 1 will float on water, and then those are the first 3 elements in group 1. They all float on water. Okay, so then the definition. So this thing, there's this word malleable, and then the other word for ductile. So the malleable means you can take a hammer and you can beat it into different shapes easily. So with a hammer, you can make a piece of metal become a block, or if you can make a block become a piece of a sheet of metal. So ductile means you can have a big block of metal and then you pull it. So you can keep pulling it and then it all become wires. So that's ductile. Then good conductor of electricity and heat. That one you know. Okay, so are there any, okay, trick again. Are there any metals who are not good conductors of electricity? Not that I know of. So most metals are good conductors of heat and electricity. Group 1 metals are also good conductor of heat and electricity. Okay? Okay.
Yeah.
Mm. So number 1 question, they say, why do metals have high melting and boiling point? So this is the so-called metallic bond that I talked about just now. So you have the atoms, the metallic atoms, they will share their electrons, their valence electrons. So you get a sea of freely moving electrons around. So the nucleus is all positive. So in between the nucleus and the atom and the electrons, right, there are electrostatic forces. So if they ask you why metals have high melting and boiling point, so what you say is you need a large amount of energy to overcome strong metallic bonds formed by the electrostatic force between the positive ions and the delocalized electrons. These delocalized electrons are the valence electrons. So the key is this. For you, it's just that 3 words here. Okay, if they ever ask you why they have high melting point. Strong metallic bond. Okay. Okay. Sorry, high density. So why do metals have high density? This is the same as why do solids have high density? Okay, so why do solids have high density? That's my question to you. If it's a physics question, then I ask you, why do solids have high density? What's the answer?
Atoms and metals are packed closely with little empty spaces between atoms in a given volume.
So that explanation comes from here actually. You have density equals to mass over volume. Okay, so density is mass divided by volume. So that's why we need to mention this. And then visually, if it's high density, then they'll be packed very closely without empty space. Okay, so then, okay, say this. So this is your metal. So you see there are hardly any space in between and the volume is probably just here. So all the spaces are kind of used up. So this is considered high density. So now I draw something here. Okay, does this represent high density?
No,
Why?
because the molecules are not closely packed.
So we have gases, liquid, and solid. Okay, please rank their density. The number 1 being the highest density and number 3 being the lowest density.
Liquid gas.
Okay, so this is you need to know. Okay, you need to know how to draw this thing. If they say please draw the structure of a pure metal, they expect something like that. Okay, now done here. So this one says explain why metals are malleable and ductile. Okay, recall what is mailable? What is ductile?
beaten into a shape.
Okay, beaten into shapes. Ductile?
Can be pulled into wire.
Good. Into wires. Okay, so now let's say we beat it. Let's do mailable first. We have this structure, I mean, the one that you saw earlier, okay? So atoms are packed, the metal atoms are packed closely to each other in a regular arrangement. So they are packed in layers. Okay, so in layers, so does it resemble the apples and oranges in the supermarket? If you have been to the supermarket. If you go to the supermarket, you will see the oranges being stacked together in layers and layers and layers, right? Have you seen that? So you can think of the atoms in pure metals, okay, like oranges of the same size being stacked together nicely at the start of the day in the supermarket. Okay, so when I talk about mailable, that means we beat it into shapes. So beat it into different shapes. So when we beat it into different shapes, that means I take a hammer and then I exert a force somewhere on the metal. So it's like me going to the supermarket and push the layers of oranges. So when I push the layers of oranges, what would happen? What would happen if the desk, the shelving there, then they put the oranges. No, they put in layers of orange like that in one heap, right?
Yeah.
So then I go
down.
and use my hand and then I go and push. What will happen?
They will all drop down.
They'll move backwards, right? So they will move in the direction of the force. So metal atoms they will behave the same as the oranges. When you push them here, that layer will move. So you see this one get displaced. They move backwards. Right. So if you have the hammer and then you beat your hammer, that means you can hammer in different directions. Then the layers of atoms, they will move according to the force. And then they will stay in their new position. So then you get the metal in a new shape. That's millable. Okay.
Yeah.
Okay. So now let's talk about ductile. Ductile means pulling it into wires. So now me with my itchy hand, I see this pile of orange again. So pulling into wires means I will not push like this, but I will exert a force this way, a pulling force. That means the forces are opposite each other. Or I can just pull one side. So when I pull one side, like this case, right, I do it this way, that means it's the same as me going to the oranges and I take one orange out. Then after I take one orange out, right, it will roll down and become here. It will drop down. Then I take another orange out, I pull it out, and then it will roll downwards like this, right? You say, just now you say the oranges will drop, right? Am I right to say so?
Yeah.
Yeah. So when the oranges drop, right, that top layer, the orange disappear. Then I pull some more oranges will roll down. And then they will roll down. And then they'll roll down. Then sooner or later, the oranges in the top layer disappear. Then this layer, second layer also disappear because they all roll down, right?
Yeah.
So in the sense of a metal, if you look at it 3D, that means this is maybe the big piece of metal originally. Then I pull it. Then the atoms in every layer roll down, right? Then it becomes thinner and thinner. So this is the old and this is the new. So it becomes thinner. Then eventually it will become super thin and super long because maybe say 5 rows of the atoms become 1 row of atoms. So when that happens, right, it becomes a wire. So after that, right, the atoms will stay in their shape and they will not become something else. So then they will be, then whatever outcome you get, right, you will get a piece of wire. Understandable? Can get? Yeah. So if they ask you, please in test paper, we say, please explain why metals are malleable and ductile. Then you will say the metal atoms are arranged are of the same size and they are arranged in layers in a regular arrangement. So when a force is applied to the metal, the layers of atoms will slide over each other easily and stay in their new position. So this is the explanation. This is the answer to this question. Okay. Then I made a circle here and then I arrow it here. So this is a blow up version, where you see the atoms and you see the nucleus, the positive ion in between. So when you exert a force, the layers will slide like that. Explain why metals are good conductor of heat and electricity. So, it's positive ions surrounded by mobile electrons. So you will say that mobile electrons allow metals to conduct heat and electricity because the electrons can move. So when you pass electricity through it, the electrons will carry the charge around. That's why it can conduct electricity. So if they ask you for answer, give them this thing. Okay? Yeah. But you know what the sentences mean, right?
Yeah.
So this is to help you when they ask you for explanation, you just give them the answer like that.